welcome to this session. If you have a question, switch on your mic and ask it, or use the chat window. And Chris will also monitor the chat window and will answer things in the chat window probably, or otherwise we'll forward your question if you don't want to speak during the session. For today, I would like to cover two subjects. One is what is new in X# 221, which we released this week. And the other is, there were some questions about dialects. What does X# do for a dialect? So I want to explain a bit what we do in the compiler and in the runtime when you change your dialect from one to the other. Okay, let's start. In X# 221, we made several changes. I think the biggest change, which we hoped that will not affect you, is the fact that we changed some implicit defaults for the compiler. In the past, several compiler options were automatically enabled when you compiled, and you had to explicitly disable them. We no longer do that. So options like, for example, VO15, which says that untyped locals are allowed or untyped parameters are allowed, are now not enabled automatically, but you have to enable them with the compiler option. If you work with Visual Studio, we are migrating your projects. So we enable those options if we know that the dialect that you're using had enabled it in the past. And I think Chris does the same within XIDE. So you should see no differences. But what you will see is that when you open your project in 221, the project files will be updated. So if you work with source code control, you will see changes in the project file. The other important thing is that several people asked for that, is that we add a so-called target framework attribute now to assemblies produced with X#. To give you an idea what that is, let me open Reflector, or IOSPy, I should say. In the generated output, we put an assembly level attribute, and this attribute says that the project was compiled for .NET Framework version 4.6. That means that the runtime knows what we expect. Now, especially for .NET Framework, there are some situations where without this attribute, the system would think that you want to run with .NET version 4, and with this attribute, it will say, okay, we expect the behavior of .NET 4.6. For example, the sorting routines inside array type, and which we use, for example, in our arrays, which have a list, and there's a sorter there, which is called, if you do an A sort, the routines are different between pre 4.5 and after 4.5. So without this attribute, the runtime would apply the pre 4.5 routines, because there was no attribute, and which means it thought we were 4.0. With this attribute, it would now apply other sorting routines. In general, you should see no difference, except when you have an array with duplicate keys, where comparison returns equal. The order of duplicate entries in the resulting array may be different because of this change in the algorithm. So target framework is used by the .NET runtime to determine what kind of behavior you expect. In general, you shouldn't see much difference, but there are some situations where this is required to use newer features of the framework. So that's why we added it to the assemblies. The third important change in the compiler has to do with FoxPro dialect, which we will cover later if we talk about dialect. And that is that FoxPro has its own defined class syntax. And this defined class syntax was allowed to inherit from system classes in the past, but we decided not to do it. And the reason for that is that in the FoxPro language, you can dynamically add properties to classes, and the support for that is only available if you are part of a hierarchy which has dynamic properties. Now, the .NET system classes don't have that, so we allow you to only inherit from the Visual Foxpro class hierarchy inside X Sharp. So we also support adding properties and removing properties, etc. And also, there are some things that are difficult to implement in the specific Foxpro code if you inherit directly from, for example, system object or system list. And by inheriting from our own class hierarchy, that is possible. I think the fourth important change in the compiler is that we added support for generic types without parameters. And one of the customers uses construct like this type of dictionary without type parameters. This wasn't properly supported in the past, but in certain scenarios, you need that. If you don't need it, no problem. On top of that, we made several bug fixes that you can find in our What's New document. The runtime, we added support for several Foxpro commands, especially in the area of the embedded SQL. So delete, where, and insert, and several other commands. I will discuss commands in the dialect section later. And on top of that, we fixed several issues that were reported by customers. In the RDD area, we made two, I would say, relatively big changes. The first one is that we now support DBF files larger than 2 GB. Internally, there was a problem with files, and I know that, for example, VO supports that, so we now allow also files larger than 2 GB. Actually, there's no built-in limit in the DBFs now for the size. Well, it's 2 to the power of 64. That's the size. But in reality, of course, there's you have to deal with the record size and the maximum number of records. Now, in 221, the maximum number of records in a DBF is 2. I always forget this, but it's 2 to the power of 31. So max long. So the maximum physical file size is max long times the record size. For X Sharp 3, we will increase it so record numbers can be 2 to the power of 32, so twice as large. But still, your maximum file size is the maximum number of records based on the record number times the record size. What we also fixed is a bug in the CDX driver where if you were creating a unique index, record number 1 was not included due to a logical error, which we never found, but one of our customers found that in the production. And this was actually fixed in one of the last betas of 221. I think the biggest changes in 221 are in the build system and Visual Studio. The build system we prepared for .NET 9 and multi-targeting. Multi-targeting means that you have one project file that can output both, let's say, .NET 9 and .NET 4.6 output files at the same time in different folders. That required quite some changes in the build system, and we have completely prepared for that. So that is also part of the things that we needed for X Sharp 3 that is now working. And in Visual Studio, we fixed several things that were broken by a change that Microsoft did. I think in May, they have disabled certain commands from the menu that were automatically enabled in the past. Commands like format document, comment, etc., insert snippet. And now we have to explicitly enable these commands, which we did. So these are working again. And when we did that, we also added commands to go to brace, which basically, if you're on a open curly, it goes to the closing curly. And if you're on a open paren to the closing paren, but also if you're on an if, it will go to the end if, etc. So this is a nice feature. I think there's a default hotkey called Control right bracket, but in Visual Studio everything is configurable. So on your machine it may be different. Also, we added commands to skip to the next and previous method. These are default commands from Visual Studio, which we have implemented. And in our situation, it skips between entities. So in a file with functions, it skips from one function to the other. But if you're inside a class, it skips from one method to the other, or maybe from one property to the other. So up and down in your editor. Finally, we've added a combo box in the editor. I'll show you that in my runtime solution. So this combo box on top is new. Now, in general, you will only see one item in this combo box. But if you work with shared code, and we do that, for example, in a common assembly info file, you will see all the projects that this file is used in. Now, and if you have conditional compilation, and an option is enabled in one project but not enabled in the other, switching between these will also automatically enable or disable the section in the editor that is grayed out. In this case, debug is a setting that's available for all projects, so you won't see it. But if you have project-specific things in here, they will switch. And this is also a preparation for X#3, because in X#3, if you have multi-targeting, so your project targets, for example, both .NET 4.6 and .NET 9, switching between these projects will be shown as two different projects in the combo, and switching in between will enable or disable features from .NET Framework or .NET 9, and also the intelligence that you see. For example, let's go through something meaningful. If you have a reference here, it will, if it's a source code reference, of course, it will find it in the source code. But if you have something like a string builder and you right click on it, now it will go to the string builder for MS Corelib 400. But if you are in a multi-targeting application where you have multiple frameworks, if you would enable the .NET 9, it'll jump to the string builder in the .NET 9. So you will actually see more methods if the .NET 9 has added methods to string builder. So switching the project will also switch reference assemblies that are used to look up and also used when you do a go-to definition. So our source code editor component here is already ready for X#3, which should be because we plan to release X#3 in the first quarter. And finally, several people reported errors in the debugger, and especially in the exception dialog. And the reason for that is that we normally have rules for identifiers in the language. When an exception occurs, Visual Studio produces a local variable with a special name that starts with the $character, which is not a valid identifier. And since the exception dialog, the expression there is interpreted by the X# compiler, we were only allowing valid identifiers, and $, was not a valid starting character for an identifier. We now recognize that you are called from the debugger, and inside the debugger, we also allow starting $, character as the first character of an identifier, which is what Visual Studio and .NET uses in certain situations, and then the error in the exception dialog is gone. So this was really a tricky one to find, but fortunately, the source code for the C# expression engine is online. So by carefully studying that, we found that they are parsing identifiers in a different way when run in the debugger. So there may be other hidden issues like that. We will, if you find them, we will fix them. But this was a difficult one to fix. Okay, what we also did was several fixes to the documentation. And one of our guests today, I'm not sure how to pronounce his name, but he's called on the, if I try it, Xinji, did Chinese documentation, which is now also included. And he pointed to some errors in the docs which we fixed. Actually, in the, maybe Xinji has seen, but in the final 221, documentation, I have added a few Chinese paragraphs by using the DeepL translation component. I hope I didn't make too many changes there, but when I tried to translate from English to Chinese and back, what came out looked a lot like what I put in as input. So I'm sure that it's close. Finally, Chris has done many changes in XIDE, and I use XIDE, but I'm not an expert. And if you want to know about all these changes, we could probably do a separate presentation about XIDE. I don't want to spend too long on that. I'm using it. It works fine for me. But all these subtle changes, I have no idea. Okay. Are there any questions about what's new? Are you missing something in this build? No questions? Okay. Then I will continue with dialects. Good. When we started with X#, the dev team had a background of visual objects and Vulkan.net. So we, our first implementation was a compiler for visual objects and Vulkan.net. But already when we were part of the graphics development team, we thought that to improve the future or to enhance the chances for a good future for X#, or in those days Vulkan.net, we also needed to support other X-based languages. And what we have done in our project is say, okay, we introduced the concept of a dialect, and dialects will control how the compiler and how the runtime work. Switching to a different dialect for the compiler is done by passing in a command line argument. If you work from XIDE, it is a property on your application, and if you work in Visual Studio, it's a property on your project. This particular project enables a command line switch, and this command line switch changes the behavior of the compiler. I will not spend too much time in PowerPoint here. I want to show you that in the compiler, and I want to show you that also in the runtime. Okay, let's go to the compiler. In this Visual Studio, let me increase the font a bit. I have opened the source code for the compiler solution, which you can find in our public repository. And inside the compiler solution, you will find some things here that are part from Roslyn, and we'll find a X# folder which contains basically our stuff. And the solution items are some links to files that are hidden somewhere in the tree, but they are a convenient way of accessing files without having to go to the Explorer or command line. Inside our compiler project, you will see that we have a command line compiler called XSC. Let's not open this. And we have the component called XS compiler. XS compiler is what we call the shared compiler that runs in the background. Both of these are basically very small pieces of code, and all the work is done inside X# code analysis. X# code analysis contains codes that we've written and contains links to code that's part of Roslyn. You see a node here called core and a node called C#. These are, I'm not sure whether you can see it, but there's an arrow in front of here. These are links into the Roslyn source code for the C# and the core assemblies. Roslyn is a compiler for both C# and Visual Basic. And what the developers have done, they have created a core layer, which is shared by both languages, a C# and a VB layer. And inside our compiler, we use the C# layer. And all the other folders here contain code that we have written. So our compiler includes both source code from the core and the C# assembly from Roslyn, and code that we've written ourselves. And inside the C# and core code, we have made some changes when needed. One of the changes, for example, is that we compile in case insensitive mode by default, where C# is case sensitive. So we have to make some changes to code that has dictionaries of type names or method names and stuff like that. The dialect support is handled by our parser mainly, but also in the back end. And what you can see here is that we have a command line parser, and I will not bore you with all the details. But what we do is we have a method to parse the compiler dialect. It's called try parse dialect, and it basically scans for the command line options and switches to a dialect and stores this dialect as part of a compiler options object. And throughout the compilation, this compiler options property called dialect is available, and we enable or disable certain features based on the dialect. And let's have a look at our parser, and I'm going to open this in Visual Studio Code, because Visual Studio Code has nice, well, there's an add-in here that has support for Antler, which is our parser generator. And this file basically describes our language. And as you can see, we have an entry point called source and an entry point called Fox source. Now, you may probably guess that this one is used for FoxPro and this one is used for the other dialects. We try to use a logical naming here. The difference, if you look carefully, is that the normal source, everything must be part of an entity. And an entity is a function, a procedure, a class, an interface, etc. In FoxPro, we allow file-wide memvars, so we allow public at the start of the source file, and we also allow memvar at the start of the source file, and we allow statements at the beginning of a source file. FoxPro allows you to have a PRG file that doesn't start with a function or a procedure, and everything at the beginning of this file is considered to be part of an implicit function with the name of the source file. So that's why you see a difference here. In the other dialects, we do not support that. And then in the end, after the statement block, which is optional, because statement block itself can be empty, we have entities. Now, entities is basically a rule list of entities, and in here you can see that our parser has properties called isFox or isXPP, and based on these properties, this is a syntax from Antler, which is what they call a predicate, and this predicate says that the Fox class rule is only valid when we are in the Fox, and isFox is a I should say a bit more about Antler, but Antler generates a class. And guess what? Part of this class is a property that we declared. It's called isFox or isXPP. And these become true when the dialect is set to FoxPro or XBase++. So the Fox class rule, which we can find here, is only valid when FoxPro is the dialect. And the same is true for the XPP class rule, which is only valid for the XPP dialect, the XBase++ dialect. So we have rules here, which also means that the defined class will never be recognized as a class entity outside of the FoxPro dialect. We also see rules here for structure, interface, delegate, event, enum. These are basically the .NET types. Global attributes like the ones that you saw in ILSpy for the framework, target framework attribute or other attributes. We have some language elements, the VO structure with members and the VO union, which are only valid in VO dialect. And I must say this isVO also returns true if you're compiling for the Vulkan dialect. So as you can see, we have enabled or disabled certain language elements based on the dialect. So the dialect controls the way the parsers scans your source file. For example, we have a separate rule, method rule for XPP and not XPP. There's a difference in the way modifiers are working, and in X you can have methods outside of classes. We have a separate role, for example, for the FoxPro declare function in DLL. So there are differences in that area. So, and inside most of the other rules, it's fairly straightforward, except, for example, in, let's check another. There's the file-wide variable rule for FoxPro is a bit different, and because FoxPro has a different syntax to declare arrays, and they allow also parentheses for array declaration. So that's why we have separate rule for that. And we also have something called the dimension statement, which is also FoxPro specific. But most of the other stuff is the same for all the languages. So the result of this language definition is a tool that can parse your source code and understand your source code. The way it works in the compiler is that the result of this is a parse tree, and this parse tree we then traverse, and we generate what we call the C# parse tree. So we convert everything to something that looks familiar to Roslyn, and it's a C# parse tree, and we have different source files here. For the core dialect, RT is for all the other dialects, which is like the common ground for Fox, Visual Objects, X++, Harbor, etc. It contains, for example, support for our own types like a date and array, and for a late bound code, for well, you name it, public and private. That stuff is stored in RT. And then inside the VO, for example, we have support for the VO structs and the unions. And as you can imagine, the FoxPro and X+ have support for their own types of classes and some other stuff. So what we do is we create a parse tree, and based on this compiler definition. And then further on in the compiler, we also enable and disable certain features based on the dialect. Let me go back. Yeah. What we also do is if you have a compile for a specific dialect and you have enabled, if you're using the preprocessor, which by default is on, then inside the header file, X#deps, you will see rules like, let me see, if dialect X++, then if you're compiling for the X++ dialect, then a certain special include file is included, which, for example, for X++ has some rules that basically compile, regress, and announce into nothing. End sequence removes garbage after the end sequence, and the same for end class and end for. And it has a special rule for commit. In the normal, say the other X++ languages, the commit command commits just the current work area. But in X++, it commits all work areas. So we have a separate rule for X++. And the same way we have a rule for FoxPro. Let's see what's in there. You see, FoxPro has the same rules that have discard anything after an end define, end for, etc. It has a command store to array, which calls a function. It has its own text too, because FoxPro has several options. And then FoxPro has a lot of commands that have rules for fields except, field like, etc. And we translate that into a function call, and we commands like scatter and gather can use this common rule basically to handle wildcard and stuff like that. And as you can see, there's also a separate use command for FoxPro. FoxPro has several other options. So based on the dialect, we enable certain user-defined commands. Maybe to clarify from what we've seen before, we saw in the language, in the ANTLER file, we saw things like do case, if, else, and if. Those are called statements in our language, or in general. So these are part of the compiler. Commands like use, on top, index on, etc., are no statements, but they are called commands. And these are actually handled by the preprocessor and translated into function calls. This was already the case in Clipper and in Visual Objects, and we adopted that model. The good thing about it is that it makes our language very flexible, because we can quickly add it or add new features to the language or specific versions of a command without having to change the base compiler. And also, those words like again or no requery would have to become keywords in the compiler if we would put them in the compiler. But if we put them in a command like this, those are basically identifiers and not keywords, and they are recognized as a part of the command. And then we still call them in blue if you have blue for the keyword, for example. But it's not a keyword in the sense of the compiler, and it makes basically the compiler faster by removing that. So you see we have FoxPro commands, etc. And also, for example, if you have a command line option to allow memory variables, then we include memvar_xh, which has support for commands like release all, clean memory, etc. This preprocessor and user-defined commands is very powerful, and it also allows you to extend the language if you want, or replace things that we did. So you can write your own release if you wanted to do something else, or you write your own commands for everything. You can do those commands if you want in your source. But as you can see here, we also include a special header file called custom devs, which is in the X# include folder. And that file is not overwritten, so you can put custom stuff in there. I would probably do it not there, but put it in the project so it's part of your source code control in your project, but that's a choice that you can make yourself. So these compiler generated, we call them macros, reflect the dialect, and you can use them to enable or disable dialect specific things in the language. And as you see, we use them to enable or disable certain commands. Let's have a look at something in the compiler. Let me see. For example, this is an area I'm not going to spend too much time, but you can see this part will actually try to figure out it will return true basically if something is an access member in the FoxPro syntax. So we can distinguish between A.B if it's FoxPro or not. And why we do that is that in FoxPro, the syntax A.B can be the field B in the cursor with the name A, but it can also be the property or a class variable B in a local object with the name A. Now, this particular code gets called and says when we're in FoxPro dialect, we know that it could be both, and then we do something specific. And we have many of those rules in the compiler where we change the behavior based on the dialect. It's sometimes difficult to actually figure out where all the customizations are. So most of the customizations are in the phase before we do actual binding. So they are in the phase where we create this parse tree, but there are also customizations later on. I would say the majority of the customizations doesn't depend on the dialect, but depends on compiler options. So there are customizations, for example, that are done if you allow memory variables, yes or no, or there are customizations if you allow late bound property access, yes or no. But there are some customizations for Foxflow. But we try to keep them as small as possible to not make the compiler too complicated and to make it not too difficult to maintain this. I think I have a slide that lists some of the differences. Where's that PowerPoint? Okay. Some of the differences between dialects are on this slide. And by the way, I will share the slides and the presentation afterward. So in the core dialect, we have class and class support. And this is available for all dialects. One place where the core differs is the fact that core does not support same line commands with double ampersand or where a line starts with the star character. This is supported in other dialects, but not in core. We also do not support single quote strings in core. Those strings have to be with double quotes or have to be with interpolated or extended. And in the core dialect, we allow the @ sign to be both address of and ref. Not all dialects support it, but the core does it. And I think the biggest one is that there are no X# types. And also we handle types just like C# does it. So we have to declare everything to be able to compile. You cannot have local without a type. Now, if you go to the VO dialect, we already saw in the parser that several things are enabled in the VO dialect, like VO struct union DLL. VO also allows private, public, and memvar, given that you have enabled the memvar compilation option. And it can also allow PSCs, @ signers, address of or ref. And in the VO dialect, the PSCs, which is something that other dialects will not know, is 0 or 1 based. So you can index a PSC like an array, and indexer depends on the option /AC, so your 0-based array option, which the one below Vulkan doesn't have. Vulkan always has 0-based PSCs. So I think there was a bug in Vulkan, but Vulkan is 9 years old now, the last version, so it's probably it's a thing of the past. But if you compile in the Vulkan dialect, your PSCs are 0-based. And you can also see that we do not support double ampersand and star for comments, and we do not support strings with single quotes. VO does. As you can also see in the last column, that if you compile in the VO dialect, the compiler will make sure that you either include X# core and X# RT or Vulkan RT funcs. If you do not include those, then the compiler will not compile because a lot of the code that it outputs depends on that. And for Vulkan, the same assemblies are required. I did do a questionnaire this week on the forum about who is still using Vulkan RT funcs, etc. There were no comments yet. So if it stays like that, they will probably drop support for this in your own runtime in X#3, which will simplify the code in the compiler a bit. Okay, other dialect.
Robert, I think about core in the previous slide, the @ operator can only be ref can only be address of in core, not ref.
Is it that if you put a VO something compiler option, then it will be ref?
No. You can. It's the VO7, the compiling option, which is not allowed in the core.
Okay, then I'm wrong.
It's a smaller typo there.
Yeah,
it's only...
I will correct it before releasing this PowerPoint.
Okay.
For X++, we have class and class syntax, and as part of this syntax, X doesn't put the visibility modifiers before variables or methods, but puts them with the name colon in the class definition. So this is enabled with the X class syntax. Methods can be declared outside of a class. So you have a class and you have a method in there, then the method is actually a forward declaration, and the method must be available after the class and class, unless you do inline method, which is basically the way we do it for the core class syntax. Add is always ref in X++. X++ doesn't have the address of operator, and there are several state or keyword abbreviations available in the VO dialect that are not available in X++. We carefully compared the X++ documentation and made sure that these are also not recognized as keyword abbreviations in our lecture, basically. I didn't cover the lecture, but that is the part of the compiler that recognizes words in your source code. The DLLs required are core and RT, and also X# XPP. This XPP contains the class definition for the X++ abstract class, and also for some other things needed by the X++. One of the things X++ does is it generates what's called the class function. And our compiler now, it didn't do it in the beginning, but now also generates the class function, which returns a value of a type that is declared inside X# XPP. So it generates the class function returns what we call a class object, and that inherits from something inside X# XPP. So that's why you need to include this DLL. Then FoxPro. Well, FoxPro has a lot of specific things, but the dialect, like I showed already in the compiler, the source code has defined class, declare in, public, dimension, local, etc. It has code at the start of the file. What is different, for example, in FoxPro is that procedures can return a value. I would call the pure language, pure dialects like VO and X++. A procedure is something that returns nothing, but FoxPro is, let's put it, flexible or sloppy, if you can also call it, and it allows you to return a value from a procedure. The biggest difference, I think, is that the FoxPro, since it's not a real compiled language, it's an engine that interprets P code, and the local variables in FoxPro are not really locals. So you can have a local in a function, and then system functions like the macro compiler or exec script can access those locals. And that is not something that most development languages allow, and it's not something that the .NET framework allows. So what we have done, we have added a mechanism I'll show you in a minute that marks functions that want to access locals with a special attribute, and our compiler recognizes that and then generates code so those functions can actually access the locals. So it's not always, because it would slow down the execution a lot. But if you, for example, call evaluate the macro or call accept crypt, and there are several other functions like type, then locals are available in the code inside these functions. Also, if you have with variables, so you do with and with, then the variable itself in the core language is only visible within the scope where it's declared. Where in FoxPro, you can call a function from within the with and with, and then access the property of the with variable. So we do a similar trick like we do for the locals. So we make the with variable visible, and if you are in a function that accesses a property from the with variable, we recognize that, for example, when your code says dot property, then we actually, at runtime, we try to figure out what is the current with variable, and then read the property from this with variable, which of course can return a runtime error if the width variable doesn't exist, or if the width variable doesn't have the property. Also, we have some special handling of expressions such as full, open paren 1, 2. In FoxPro, if you read source code in FoxPro with this, you have no idea if full is a public variable that contains an array and you want to have element 1, 2 from the array, or if full is a function and you want to call it with 2 parameters. That is dirty. And if you enable the compiler option fox2, this is also allowed in X#. I will not recommend it. Actually, I would recommend to disable /fox2 and use square brackets for arrays and not have this ambiguity in there, because the way to resolve this, we have to actually delay evaluating this expression until runtime, which is not nice. It does work, but it's dirty. Well, the last thing that I want to mention here is that the if variables are in Harbor are optional. So in Harbor you can have if and then a condition, comma, nothing, comma, the false variable. This is not allowed in the other dialects. In the other dialects, both the true and the false expression must be there. If you enable Harbor, we will input the compiler will generate a nil in there, and so nil for the expression that's omitted. In theory, in Harbor, you can even have an if with a logical condition and no expressions at all. Doesn't make sense, but Harbor allows. We allow it too, but your code still doesn't make sense. Unless, of course, the logical expression that you evaluate has side effects, because then it does make sense, but then you can just call the logical expression without. Okay. Runtime, and then I also want to show you what we are doing for local functions, accessing local variables in FoxPro. Okay, if you compile an app, you will include references to X# core, X# RT, and the compiler then calls code in there, but it also stores the dialect in the resulting DLL, so the runtime can see what the dialect is that we compiled for. Now, it doesn't expect all the all the DLLs, but the dialect is expected from the starting exe. So if your app has a C# exe, and then the rest is X#, you will have to manually set the dialect. Now, let's have a quick look in the compiler, and let's go. So what we have X# is a runtime state. So nowadays, modern development, people are recommended to do stateless coding. Well, Xbase is not stateless. In fact, it's full of state. State is the list of open areas. State is the current setting for set deleted or set exact or set whatever. And part of this state is also the dialect. And what we do, I can probably better show it in an ILSpy. This is the assembly X# RT. And our compiler has inserted this particular attribute in the assembly. So you can see that this assembly was compiled with the X# compiler 221.5, and it was compiled with the dialect VO. And the main app of your program also has this compiler version. Now, what our runtime does is when the runtime is initialized, it tries to get the entry assembly, which is the main assembly, and then finds the compiler version attribute and passes the dialect there. So this is only done once when the runtime state is initialized, and we initialize the dialect from this compiler version attribute, which is an assembly attribute. Now, if you have a startup that is not an X sharp, then either you have to put this attribute in there yourself. You can also put the attribute like this in your C# assembly. You'll probably not put X# in there, but then C#, whatever. But put the dialect colon and then the name in there. Or you have to assign the dialect, which is part of the runtime state, and set it to the right value. Now, this is important because certain behavior inside the runtime depends on this dialect. You will find in the runtime code places where behavior is different depending on the dialect. Okay, one thing that I also want to show is the, I should probably do a test. Now, first let me show it in the runtime. In the macro compiler, but also other code, FoxPro allows the macro compiler to actually access locals and update locals. So in FoxPro, you can evaluate a string that says foo is 1, and if foo is a public variable, then after you call evaluate, foo will have the value 1. Now, that means that and that also allows it to do it when foo is a local variable. Now, that is not common, and we have marked several functions in the runtime with a special attribute. It's called need access to locals, which says this function wants to see the locals and wants to maybe update the locals. The true here says compiler, this function can actually update locals. And you will see, for example, the function type, which returns the type of a variable, will never change the local. So this needs access to locals false. Now, if the compiler finds this attribute on a function that's called, and if the dialect is FoxPro, then the compiler will actually output extra code where it stores a name value of the locals in a specific place where it can be accessed, and it is the same place where it finds privates and publics. And then if the parameter is true here, then after the call to type or after the call to evaluate, it'll ask if any locals were updated, and if there were, then it actually is going to read the locals by name again, and then assign them the value that they have after the call to type. Now that is overhead, and it's not recommended, but it is the only way that we were able to emulate this behavior of FoxPro. And I didn't prepare that, but maybe I can do that here. Let's just do something. By the way, do you see this typing here, this in gray? I showed this also during my session in Munich. This is Copilot. So Copilot knows that when I have an extra string, I often store hello in there. And that the most common thing after that is to display it. But Copilot is wrong here because I want to now to call type X. So this should return a C for a string. And let's see if this compiles. My machine is maybe a bit slow because I have a development version of Visual Studio and a development version of X Sharp, and I have a lot of stuff on, but it'll compile. Okay, let's see it to start. Now, what you see here is that type, this is the compiled version of type, actually has this attribute, and the compiler saw that too. And what it does, it says, okay, before calling type, it stores a name and a value of X somewhere where also the memory variables are. And after the call to type, it clears the list. So this returns, I hope, C. And it does. I'm not sure if you can read it. I'll besides want a bit. Doesn't work. This is the new terminal. Okay. Anyway, this has C.
It's fine. It's fine.
Yeah. For example, if I would do this, now the resulting exe will, where is it? Oh, it's there. Will actually evaluate this. And since I've marked evaluate with needs access to locals true, so it can update, and in this particular case, it will update. It calls, are the locals updated? And when they are, it will assign the new value of X to X. So let's show X then too. And it doesn't work. Isn't this great? Now I'm wondering why it doesn't work. Let's try this. It does work now. Okay. So apparently I need to talk with Nikos about translating the single equals to an assignment operator in the Foxtrot dialect. So I just found an issue. Chris, can you make a note of that?
Yep. Yeah.
So
it's similar to another thing from this
what do you
week.
see? You see something else now too?
It was all together. Wasn't it something else in the microcompiler that? Yeah.
Anyway, to give you an idea, what happens is that you see a lot of happening. This is debug version of the runtime, but so this is where it actually puts the locals. As you can see, locals are stored somewhere in that has to do with memory variables. So we basically have a list of memory variables, publics and privates, and these locals are also stored in the same area. And inside evaluate, it'll do, let's see if I can find it. I'm not sure if this is the one. No, it's not here. A memfar get. No, I'm not seeing it. But anyway, the I probably set the breakpoint in the wrong place, but it goes into there, and if X was a public, it would work, but now X is a local, and it also works. So we basically emulate the behavior of FoxPro that you can in certain runtime functions like evaluate, like exec-script, but also SQL and stuff like that, that you can access locals, either read locals or modify locals. So this is a change that we did for dialects. Other dialects will not have this behavior. So if I would compile this with the VO dialect, then it wouldn't work. Let's just give it a try. It's probably, I shouldn't probably try it because I didn't prepare that, but it's always fun to see what happens. So let's go to VO dialect. It does work. Come on. Okay, it does work in VO dialect. And if I disable memfiles. Now you see that it did change. Now it doesn't put the local, and it doesn't. So evaluate returns X, which is a private, basically declared inside the scope of the macro compiler. It returns Chris, but the original X from this function is no longer updated, which is I don't want to be negative about Foxrow, but this is how it should be. Locals should not be, you shouldn't be able to touch a local. Local means something about visibility, and why should the runtime be allowed to touch locals? We have to do something special, but it works. Okay. The dialect, like I said, is stored in the runtime state. Many of the dialect-specific things are already defined at compile time, because the compiler decides to link in certain functions, yes or no. There are some places in the runtime where we actually have different behavior depending on the dialect. About the runtime, the core has no runtime. We know that. It's not required. There is an X# core runtime, but it's basically an assembly that is compiled in X# core dialect and has functions, code that does not depend on the X-based types like date and array, etc. The VO dialect requires X# RT and X# core, and if you use VO SDK classes like GUI classes, etc., then you also need to include X# VO, because the V object type is declared inside X# VO. And also, if you use, for example, the VO dialect, then your default RDD will automatically be set to dbf NTX. And there is a class called OLE auto object, which is also there. And depending on the dialect, if you create a dbf, if you do it in the VO dialect and you have a dbf NTX or a normal dbf, then the ANSI bit in the dbf header will be set if you have ANSI enabled, which sets basically for a dbf without memo, the type, the ANSI type is 0x7, and the non-ANSI type is 0x3, which we still have from dbase 3. So that's a difference, basically. Vulkan has the same requirements for the DLLs as VO, but for example, there's different handling of no method and lane-bound code. We have our runtime basically makes a distinction between VO and Vulkan, so we have the same behavior. I will not go into details, but you should be aware of that. The X dialect has a completely different handling of correlations. These are the sorting tables. There is a resource inside the X# XPP assembly, and depending on if you set the correlation in X++, it'll use those tables for sorting. And the sorting, that is sorting for string comparisons, for example, if you use an A sort or something like that, but also for sorting during indexing with dbfs. Also, X++ allows you to access usual variables with an array operator if it's not an array. In X++, you can access strings with an array operator and you get basically a substring, or you can access numerics with an index operator and you can get the bits of it. So we have enabled that. And the X++ assembly also has code for dynamic class creation and class functions. And for example, a difference is that if you run X++ and you have a field put or field get that fails, X++ will not complain, and all the other languages will complain. I'm not sure if it's a bug in X Plus or not, but we have a customer that depended on that he didn't want to see a failure, so we suppress the error now to be compatible. And it has, for example, XML functions that were part of a third-party product in X Plus, but we put them in the X# XPP assembly. Finally, the Fox Pro. There's a startup code in the Fox Pro assembly that changes some defaults. And I think the biggest defaults are that an uninitialized usual, which is basically the type of variables without a type, is different in Fox Pro from the other languages. In Fox Pro, uninitialized variables have a value of false, where in all the other dialects, initialized usuals have a value of nil. And nil is something like nothing, and false, well, it's illogical. If you call a function like isNil in the runtime, it'll also return true for the uninitialized Fox Pro usuals. But if you assign a value false to a usual, then it will say, no, it has been assigned. So now it is not nil, but it is illogical, basically. It's a bit complicated, but it works. Also, the default RDD, if you switch to the Fox Pro dialect, becomes dbf VFP, which is the RDD that supports the Fox Pro field types like datetime and auto increment, etc. And it supports also collations in the Fox Pro CDX files. And Fox Pro also automatically locks replace, delete, recall commands. So if you initialize, in the initialization code of Fox Pro, we set a specific auto lock function. We enable that so that your replace command will work without locking. Again, I'm not sure if that is a good or a bad idea. I personally would not want to have automatic locking in a multi-user environment, but that's the way it works in Fox Pro, so we've enabled that. Finally, there are some specific functions or versions of functions in the Fox Pro runtime. For example, string has a different default behavior if you just pass in a number, and like has a different behavior with regard to case sensitivity, etc. So these are some of the differences in the code. And I want to show you what, for example, what happens in the Fox Pro initialization code. Where is it? In here, you will see an init3 method. An init method is a method that's automatically called a startup, and it does something with error messages. It's not important right now. It monitors the dialect. If the dialect is changed, it monitors that, and it calls a method here, and it initializes the Fox state. And as you can see, memvar, I don't know, I don't want to explain that, but we also put a special memvar put in here because the memory variables could be of type Fox Pro array, and we enable auto lock and auto unlock, and we also have a special functions for adel, alen, ains, and show array because Fox Pro arrays are a bit different from the arrays in the other dialects. And as you can see, like I said on the top here, there's a dialect change event landed. If the dialect is changed somehow, and normally that shouldn't happen in your code, but during our runtime tests, this happens a lot, that we actually initialize or clear the Fox state. So in the initialize, we set these things, and in the clear, we basically auto lock gets reset, and the array helpers get reset. So it falls back to the default behavior. And in here, for example, you see the implementation of the Fox auto lock. It gets the current work area. If it's shared, it tries to lock it, and that's it. Unlock does something same. You see the Fox memvar put allows you to, the difference here is that if you have a Fox Pro array and you assign it the value, let's say 42, it doesn't get changed from a array to a long, but actually the array gets filled with the value 42. So that's what happens in this particular version of memvarput. So if you assign 42 to a public, then in the Fox Pro, it'll fill the array with 42. And if it's, as you can see, we also have code here that says compiler option Fox2. And there are several other like these. So what I said is if you compile your application with the compiler will insert a piece of code that sets the dialect, but the compiler will insert more. If you look here in, let me see. I'm not seeing it, why not? Okay, the decompiler hides it now, but it generates a piece of code at which gets called a startup, and this basically sets the compiler options, several compiler options, as part of the startup code. So compiler options, overflow checking, VO11, VO13, Fox2 are set. So at runtime, we can see was the main app compiled with Fox2, which is the Fox Pro compatible array handling. And if it is, then assigning 42 to an array will fill the array. So if you compile without Fox2, then this particular code will not be called, but it will basically call the normal memvarput. Okay, you will see this compiler option in several other places. For example, in the implicit converter, if there are overflow, this is the, Chris, help me, what does VO11 do? I always forget it.
One moment.
Is that compatible?
Arithmetic conversions.
Oh yeah, compatible mathematic conversions. So if your app has compatible mathematic conversions, then if you do a, this is probably not a good one, but let's look at the, oh, this is, okay. It basically does conversion to int, or if it's not, it does cast it to short. And depending on the overflow checking, it does a checked or an unchecked conversion. So if the value, the float, is too large for the conversion to short, depending on the overflow compiler options, you will get a runtime error, yes or no. And for normal code, this is done at compile time, but since this is a number stored inside the usual, we have no idea here what it was. So we save these compiler options as part of the runtime state, so we can change the behavior of these operations depending on the value inside this compiler option. Okay, which makes me wonder if we shouldn't do an overflow check over here. We probably should.
Robert, that actually makes it compatible to VO. So we have added hacks and made it work exactly as in VO. So
a normal developer, let's put it like this, should have done this overflow checking here too. Apparently, as Chris just enlightened me, VO doesn't do it. Now, I'm not sure what X Plus does. If you have a long in there and you cast it to a short, probably it doesn't have that because there are no types in X Plus, so everything is a long or a floating point number. But in VO, we did have types, and that's probably, we do exactly what VO does, which is dirty. So if the number is, if the integer is, let's say, larger than the maximum value of a short, apparently in VO, it would just return a short and throw away the excessive bits. And we do the same here. It's ugly, but it works. Okay, where is my PowerPoint? Yeah, I think it's 5:15. I have hour 15. I've covered most of what I wanted to show. Are there any questions? Are you missing something? No.
Just a reminder that everybody is muted. So
Yeah, but they can use the chat window. Do you have access to?
no, I'm saying for anyone that might be trying to talk, but is actually muted.
They can unmute themselves. There's no problem.
Yeah.
So it was clear. You have no questions. That's excellent. Future changes to the language will also be part of either in the compiler for future change to dialects or in the runtime. Yeah, Wolfgang thinks it's interesting to see the access to locals. The implementation is not very complicated, but it took me several weeks to figure out how to do this. And it's kind of dirty because it's not just that we do that, but then at every place where we have a function call like that, we have to find all the visible locals and then make sure that these are included, and it's a challenge. And if you have lots of locals, you will see lots of local puts in there. So, and then again, you shouldn't have lots of locals. You should have small pieces of code that with one screen full with handful of locals, and then it's okay.
And that's only for Fox Pro dialect.
Only for Fox Pro, and only when you have memvar enabled. So if you don't have memvars enabled and you don't have the Fox Pro dialect, you will not see it. Anyone else? No?